Well, here are the answers to problem set 2. Question 1. You're given two vectors. One is 8i minus 3.7j. The second is 3.9i minus 8.1j minus 4.4k. To find the sum of the two vectors, you got to add up the i's, the j's, and the k's individually. And to find the length of the vector, square all these coefficients, add them up, and take the square root. And you would get 17.3. In question 2, you resolve the vector into two components. Those are the vectors v1 and v2, and you get v1 x is negative 6.6, v1 y is 0, while v2 x is 8.5 cos 45, and v2 y is 8.5 sin 45. As shown in the diagram. Then total Vx is V1x plus V2x, which gives 0.59 negative meter per second. And Vy is again V1y plus V2y, which is 6.01. And then to find the magnitude of the vector, square the two components, add them up, and take the square root. To find the angle, tan theta is Vy over Vx. It gives 10.17 for tan theta, and theta is actually it's negative, so it's negative 84.38. Question 3. It's flying at 735 km per hour, 41.5 degrees west of north. So break it up into its components. 735 cos 41.5, Vx is 735 sine 41.5. Well, the unit is kilometer per hour for both. Now, to find the displacements in 3 hours, just multiply the velocities with 3. So the x displacement would be 1461 kilometer, and the y would be 1652 kilometer. Delta y is to the north and delta x is to the west. And question 4, the velocity is 6.8 and the horizontal displacement is given, and you have to find the angle. In fact, the two angles. Now, since the horizontal component is a constant, that's the only equation you can use. And the horizontal component is 6.8 cos theta delta t. And looking at the vertical, the initial velocity is 6.8 sine theta. Obviously, I'm going to correct that. A is negative 9.8. Delta t is to be found, and delta y is 0 because it lands back on the same horizontal level. Using the king, that's not right, because Vyo is 6.8 sine theta. Remember, delta y is 0, so obviously 0 is equal to 6.8 sine theta delta t minus 4.9 delta t squared. Rearrange that equation to make delta t the subject. and plug it back into this equation. Simple substitution there. Rearrange, we're trying to find theta. And mathematically 2 sine theta cos theta is sine 2 theta. So you get us 0.42. And no, it's not 0.84, that's a mistake. So what I get is 0.42. So sine 2 theta is 0.422 theta is the inverse of that, which gives 25 degrees, and therefore theta is 12.5 degrees. Now that's a mathematical identity which we have been using. Now the formula for horizontal displacement is v squared sine 2 theta 1 by g, but assuming there's another angle, we could write it as v squared sine 2 theta 2 by g. Cancel the like terms. And on the right hand side, it can be written as sine 180 minus 2 theta 2, because sine 180 minus an angle gives you sine of that angle. Rearrange that and simplify to get the sum of the two angles should be 90 degrees. Therefore, there are two angles with the same velocity to get the same horizontal displacement. And when you add those two angles, you must get 90 degrees. The horizontal displacement is called range. Here I am trying to give you some ready-made equations that only work when the projectile goes from ground to ground or lands back on the same horizontal level. For the time of flight, it's 2v0 sine theta by g. For the maximum height, it is v0 squared sine squared theta by 2g. And for the range, which is displacement along the x-axis, it's v0 sine, it's actually v0 squared sine 2 theta by g. Question number 1, the height and the range are given. Obviously, this is not drawn to scale. Again, the initial vertical is 0 because it's projected horizontally. And delta y is 45 meter. So use this equation. To get delta t squared is equal to 2a delta y. 2 delta y by a. Substitute and calculate to get the time as 3.0 seconds. Now considering the horizontal, we know it's a constant, so that the only equation that can be used is delta x is vx times delta t. We're trying to find vx, and therefore divide 24 by 3 to get 8 meter per second. In question 6, the bullet is fired horizontally from 75 meters away. Need to find by how much it misses the target. Speed is 180 meters per second, and again, because it's fired horizontally, the initial velocity is 0. A is 9.8. We've got to find delta y, and we do not know delta t. So looking at the horizontal component is the entire 180 meters per second. Delta x is 75, and we can find the time using this equation. gives 0.42 seconds, and we can use that information in the equation delta y is v naught delta t plus 1/2 a delta t squared. That term becomes 0, so plug in the numbers and calculate to get 0.86 meter. Now that's by how much it misses the target. The second part of the question is by what angle should he adjust the rifle, obviously upwards, so as to hit the target, and that's simply delta y by delta x, that's tan theta, which gives in calculation 0.66 degrees. Well, I'm just labeling the maximum height, the time of flight, and the horizontal displacement here for projectile. And also notice that the vertical component of the velocity decreases and becomes 0 at the highest point, and then increases just before hitting the ground, becomes exactly equal to what it was at the beginning. But throughout the motion, the horizontal component is a constant, it does not change. In question 7, as usual, the horizontal is 62.5 cos 34.5. The vertical is 62.5 sine 34.5. To find the maximum height, we use the vertical component, initial. A is negative 9.8 because it's first going up. At the maximum height, the velocity is 0. And we need to find delta y. Use this equation and plug in the numbers. To get the maximum height as 1253 by 19.6, which gives 63.93 meter. Now to find the total time, again use the initial vertical, and A is negative 9.8. And we know that delta y is 0 when you consider the whole motion. So use this equation, substitute, to get delta t as 35.4 divided by 4.9, that gives 7.22 seconds. Now to find the total range or horizontal displacement, the only equation that can be used is delta x is the horizontal multiplied by the time. Gives 372 meter. Now remember that the horizontal velocity never changes. So it is still 51.5, but the vertical velocity does change. The initial is 35.4, acceleration is 9.8, and we got to find the final. And the time is given as 1.5 seconds. Now it's negative 9.8 because at first it's going up. Use this equation and calculate it. is 20.7 meter per second, and therefore the actual velocity is going to be the sum of the squares of these square root. It's 55.5 meter per second. Number 8. In such problems, remember that the velocity is constant. Therefore, we can use only that equation which talks about time as being displacement by velocity. And so if you take the vertical displacement divided by the vertical velocity to get the time, and apply the equation for the horizontal, Vx is 0.4, the rate at which water is flowing multiplied with the time, to get 66.67 meters. That's how far away the swimmer would be. And in question 9, it's almost the same thing. In this case, we could find the time to cross the river by using the vertical displacement by the vertical velocity, which is 260 divided by 1.70 cos 45. Just 216.7. Now, considering the x-axis, no, it's given that it's 110 meters away. And now the velocity, you got to be careful here. Now the velocity is 1.70 meter per second, which is this way. And then take away the velocity of the water, and then multiply with the time. That's simple calculation that will give us the velocity of the water with respect to the shore. And we get it as 0.7 meter per second. And I hope this YouTube video is useful towards preparation for your first exam. Thank you.